of a theorem? Yeah. Now, would anybody have the? You know what might be useful, and even for myself. Okay, I would probably make up a theorem. Yeah. So do you know what I do? I'd sort of explain it in your own words to the best of your ability. So what I'm going to do is I'm going to think of an example of a converse theorem. Does that make sense? Okay. So what I'm going to say is all. Let me see. Trying to think of a good one here. Okay. All. Yeah. All squares are parallelograms. Agree or disagree? All squares are actually parallelograms. Really? What is a parallelogram? Okay, let's begin. What's a parallelogram? A shape, and and we'll go for a square. I'll write square underneath as well. Okay, ready? So, would you agree that parallel has two sets of parallel sides? Does a square also have two sets of parallel sides? Would you agree? Okay. Would you then agree that in a parallelogram, opposite sides are the same length? As an example, yellow equals yellow, and in a square, yellow also equals yellow. And in a parallelogram, as you said, opposite sides have the same length. Blue equals blue, and blue equals blue, right? It's a bit like parallelograms are cats, right? And basically, the square is a line, okay? So all lines are cats, but not all cats are lines. Do you get what I'm saying there? So if I try to use the example, right? So if I say all cats, all lines are cats. See the way lines is the subspecies, the really narrow one, but lines are great. Are all lines are cats. But if I change that around, does it work? All cats are lines, and this is the exact same thing. All squares are parallelograms, but all parallelograms, all parallelograms are not squares. Sorry, I actually have to write down all parallelograms are squares, and we just say that's false, isn't it? So this is an example of a converse of a theorem. Right now, if you look at the conditional, okay, so that's more of a statement than a converse of a statement, okay. Oh, let me do that. So here's we're going to try another one, all right? And once again, this might be the one you learn off by heart. Just keep it in your bag, so to speak. But this like in a way, in my maths tables, if I had it, just says my go-to one, all right? So we're going to do an isosceles triangle. Ever do an isosceles triangle? What is an isosceles triangle again? Two sides of the same. Okay, lad, and if two. Oh, every day. No, if two sides are the same, then if two sides are the same, then two angles have to be the same as well. So if two sides are the same, two angles have to be the same. So here's what we're going to do, okay? We're going to do green, green, all right? It doesn't matter which way we do it, okay? So, in an isosceles triangle, so everybody agrees in an isosceles triangle, the angles. Now we're talking about the green angles, aren't we? The angles opposites. The angles opposite the equal sides. This is the one I'd learn off by heart. The angles opposite the equal sides are what, lads? What can we say about the angles opposite the equal sides? are what? Are equal in measure or are the same size. Now, what I'm basically going to do here, guys, this comes up a lot in the leaving, this particular question. Okay, it's come a few times. So, what we want to do is what is the hypothesis? That's the hypothesis. What's the conclusion? Oh, sorry. Uh, that's still the hypothesis, isn't it? And then what's the conclusion? Are equal in measure. Okay. Now, how do I swap this around? Yeah. So the converse would be if sorry. So we specify it's an isosceles triangle, don't we? So if two angles in a triangle are equal, if two angles in a triangle are equal, what does that mean about that triangle? That triangle is isosceles. Okay. Actually, sorry, let's just do this again. That triangle is. Sorry, gents. On the see the green stuff there? Sorry, I think it should have been like this actually. It specifies an isosceles triangle, and then the conclusion is the rest of it. Sorry, my bad. Specifies an isosceles triangle. Once you hit the isosceles triangle, you go angles opposite equal sides are equal. Now in this one, you're talking about the triangle. If the angles of the triangle are equal, no bother. Then the conclusion is that triangle. Knowing this information, the triangle is isosceles. Is that okay? Now, how do you explain what is meant by a convex of a term? The green part is what, guys? The hypothesis. Oh, we're still going. Still works. Let's keep going. Video's still rolling, okay? So, just gonna rub all this out now. Okay. Oh, all right, doing my best, all right? All right. Now, gonna go down the bottom here. Okay. I'll try to this out, okay? What do we say again? The converse of a term. You should probably take this down. Is formed by swapping the order of the hypothesis and conclusion. And we gave an example above, didn't we? Isosceles was at the start, conclusion at the end, and then we swapped it around. Okay. Isosceles triangle. Angles. The angles opposite the equal sides are equal in measure. All right, gents. Write down FTC. A term, of course, can be used. Write down FTC and state the theorem. Okay. I'd say that there's 1, 2, 3, 4, 5. But everybody agrees there's 6 angles. Is it 6 or 5? 6 angles. Is that okay? Then, because there's 6 angles, a full circle is 360. What does that mean about each one of those angles? Huh? 60. Have I answered FTC? I don't think I have. Okay, but we're quite lucky now. Just look at this. Where's F to D to C? Oh, sorry. My fault. I'm filling that information ahead of myself. The term we're looking for is angle in a semicircle is 90, 90 degrees. Okay. Does everybody see this semicircle lined up? That's the diameter. And all 3 points around the circle. So the angle in a semicircle, this one up here, happens to be 90. Is that okay? All right. What? Angle in a semicircle is 90 degrees. Okay. All right. What's the next thing I want from me? Is that it? Is that all I wanted? Yeah? That's disappointing. All right. All right, guys. Okay. What does it want? Wants us to draw a. Okay. All right, lads. Can we count out those points, please? Sorry, 1 sec. 6 minus 1. Yeah. What's the next one? Whoa. 12 minus 3. That's a long way over. 12 minus 3. Yeah. 8, 5. Okay. And D. Okay. Now, lads, I'm going to link this up with line segments like so. And to me, it definitely looks like a parallelogram. Everybody have to draw that, okay? Okay. Now, okay. Back in action. Okay. Going to take this answer here. I'm going to put it onto our current page. So, be here in a second. Let's see. There we go. Now, lads, here's the parallelogram from this question. Okay. I plot all 4 points, and they're over here like so. Happy days? Okay. Now, describe 2 different ways of showing using coordinate geometry that points form a parallelogram. No bother. Here's what you can do. Ready? One way is really long. Okay, so parallelogram. All right. In a parallelogram, you can find the slope of DC. Everybody happy find the slope of AB. Then find the slope of DA. And find the slope of CB. What should happen? The slope should be there. Okay, the 2 blue lines will have the same slope, and the 2 yellow lines will have the same slope. And you'll be using y2 minus y1 over. Do you remember that from junior cert and slope formula? No. What? Not from last year? All right, fair enough. What have I told you that this won't affect your test and we should move on? Okay, we'll catch that in the geometry revision at a later date. Okay. The second method, would be like this. The second method is that you get the equation of the diagonal. Then you get the equation of the. Oh, this way is so long though. It's not really the best one. Actually, I have a better one. What you do is you get the area of a triangle, get the area of the top triangle, get the area of the bottom triangle, and if both areas are the same, it has to be a parallelogram. Because a parallelogram. There's a formula in coordinate geometry which we will revise over eventually. Called a half x1 y2 minus x2 y1, and any 3 points in the triangle, you can find the area really quickly. Okay? Remember doing that formula? Okay. So you did do quantity geometry. You just did revise that. Okay. I have a way of doing that. Okay. Lads, next one. This is more useful. Okay. A photograph shows a dockland still in Hamburg, Germany. The diagram below is the side view of the building. Parallelogram. The parallelogram is 29 meters high. Top to bottom edges are 88 meters. Find the area of the side of the building. Uh, I don't know. I have a bit of a problem here. I have a problem with this question. Okay, and I'll be keen for one of you to read the back of the book to tell me the answer. I don't know if they're talking about this being the 29 or the start edge being the 29. I have it in my head just to multiply 88 to 29. And it's out the back of the book. Just checking now. I was thinking about that, so I just want to know the simplest answer first. I check it in my book, and if that's not the answer, then I come up with that big. Now, guys, well, what happened here was what is 88 times 29? Okay, if in a test that you're confused, like I was there, one of the options is considerably harder than the other one, isn't it? So, in this case, if you are confused with the test, we'll say, I read this as height, vertical height is 29. Here's my answer. Minimum loss of the most. Okay? Now, if you want, if it was to be the other option, here's what I would have had to do. Because actually, believe it or not, there's no way out of it. You won't be able to calculate the height from it. So actually, there was only one option. Same thing you could have done. There's not enough information to calculate the height. Okay, B to D have two triangles there. Problem is, you need to know the length of the curved side to calculate the area of that triangle. So once again, the dead end. There's actually only one rule. But what's the height? Oh, you want to? Sorry, we're having two different conversations. What you want to do there is you want to say that that's 29. That's 88. Yeah. Because the two triangles are the same area, and then you just multiply it by two. But in this case, we know that it's a parallelogram, and we know that the two are going to be the same height anyway. What did we say that number was again? 52. Okay. Now, find the area. Done. Okay, we have the area. If BD equals AD, oof, BD equals AD. Okay. What does that mean about the triangle here? It's isosceles, isn't it? Everybody agree with that? And then it wants me to find BC. Would everybody agree that BC is the same as what, guys? Well, yeah, BC is the same as AD. This is tough. This one has me thinking. Okay, so what do we know so far? We know that that's 88. We know that the height as well. 29. Okay. And it wants BC. It's not just half base but height. I know what to do. I think I know what to do. So, because it's an isosceles triangle. Oh, we have it. Because it's an isosceles triangle. I'm just slow this morning. Just give me a second. Okay, it's all right. I have my own moments even in my own subjects. Now, because it's an isosceles triangle, so I'm sort of thinking about how to deliver to everybody at the same time. So, because it's an isosceles triangle is cut in half when you drop it down from the peak. See the way I dropped it down from the angle and cuts in half. Only for isosceles and equilaterals. So I would put that up there, and for me that cuts that into 44. See that little length there? 44. And this is a very useful one for later. Okay, and this is 29 as discussed. What is the only term I can use to get that guy out? X squared equals 44 squared plus. Would somebody do me a solid and put that in and tell me what it is? 44 squared plus 29 squared. 2,700 and square root it. $52.69. Okay, that was tough. The line BC and AC are parallel. Find the distance between. Oh, this one's good as well. They're all great. Now, lads, look at this. What did we say the area of the parallelogram was earlier? This is actually a really good question. There's lots in this. Sorry. Cancel. Right, here's what we're going to do. Ready? For God's sake. Give it a second. Just having a bit of a mad one on me there for a second ago. Hey, this is a good one. And this is not your first time seeing me do this either. Give me 1 sec. I had to start testing now in a second. But look, here's what we're going to do. We're going to grab this guy. We're going to send him to another page, okay? Now, it wants to find the distance between the two parallel lines. Okay? Give it a second. Come on. There we go. It wants me to find the distance between these two parallel lines. Now, what did we find out earlier? Sorry? Found out that that's 50 points. Okay. We found out this is 88. Lads, you looking? We know that the area of the full thing is 255. Now, all I'm going to do is this. Okay? Very simply. Going to rotate this like so. Now, that looks like it's wrecking your head, okay? Here's what we're going to do. All we have to do is find the vertical distance from B, basically B to D, isn't it? That vertical distance. Now, remember what we said earlier. You have to make a 90-degree angle. So, this yellow line multiplied by this green line gives you the area of the parallelogram. That's called the green line D for argument's sake. Ready? So, the yellow line, which is 52 points, multiplied by D, which is the perpendicular distance between the two lines, okay, has to equal 2552. Will somebody do me a favor and get 2552 and divide it by 52.69? 2552 and divided by 52.69. What do we get? 4, perfect. Okay, guys,